Sage Modeler before we get started with the presentation, the workshop for today? Everybody will notice that Buren put in the chat sort of the link to Sage Modeler. That's a really important link as you go forward. You're going to want to just put that in a nice little place that you can always just refer to it pretty quickly, so you don't always have to go searching for Sage. On the other hand, if you do a search for Sage on the web, you can always find it too. Okay, well, why don't we get started with today? Is that okay, Buren, and get started for today?
Yeah, yes, please.
Okay, so I'm going to share my screen, and we're going to continue with our work with Sage Modeler today. This is day 2. We're going to have 3 days just of sort of learning how to use Sage. So I think everybody can see my screen okay?
Yes.
I'm going to put the chat up so I can see if any messages come across. Okay, so we're going to sort of do a little bit of reviewing here at the beginning. So we're building models, in particular, Sage focuses on system dynamic models. But no matter what model we're building, we always have a question related to a phenomena that we're asking, we're trying to answer. We're always planning, where we first need to think about what are the objects that we have in our model, but then what are the factors or variables associated with those objects? Because it's the factors and variables that actually can change. We build relationships between those factors, and hopefully that set of relationships can really provide a sense of how that phenomena works. We then revise it based upon if we see some issues with it, maybe through discussion or through data, and then we share and we communicate those findings. So building models really gets students into a lot of really important scientific practices and skills that they really need for the 21st century as they go forward, both with their education and with their life. So, you know, we also have a little visual representation of it too: a plan, build, share, evaluate, revise. So we saw yesterday that with Sage, you can actually generate system diagrams. You can test relationships between variables. You can make sure those variables work together by running simulations. And one of the nice aspects behind Sage is it's, while it can generate some quantitative data, it's actually a semi-quantitative data tool providing some scaffolds for students. And it supports both static and dynamic modeling. We're going to continue primarily today with static modeling, and then we'll float to dynamic modeling, primarily because most of the work we'll be doing, it will focus more on static modeling than dynamic modeling. Yesterday, we actually got into a bunch of features. We learned how to launch Sage. We learned how to download images, select the models and their relationships, label variables, make relationships, simulate your model to collect data, test relationships, make a graph, various ways to save the models, and we also shared our models. It was nice that I was able to look at everybody's model last night in the evening when I got home. So remember, static equilibrium that we're focusing on really focuses just on linear cause and effect relationships. Not necessarily linear, they can be exponential too. That's actually an error. I'm gonna take that out. Actually, there you go. You might want to change that on your PowerPoint as well. So it focuses on cause and effect relationships, fairly direct. So if there's an independent variables, there's an immediate effect on the dependent variable. And as they look, they're basically snapshots, but you can collect data at different snapshots and see what would happen to your dependent variable. And once again, their static models are good when we have systems that aren't changing. If you're really working with systems that change across time, like let's say climate change, then it's more important to use dynamic modeling. Although static modeling can work. So that's just a quick review of what we did yesterday. And I already asked to see if there was any pressing questions. But if there is, please put them in the chat or speak up. There were a couple of questions yesterday that came up that I want to show you how to focus on them. And one is, can you have numerical scales when you're doing Sage? And so I'm going to show you how to do that. If you open up Sage Modeler at this time, and I'm going to launch Sage. And I'm going to open a document.
The presentation is still showing the slides, so I guess you have to stop
Yeah, that's
again.
Sorry about that. I'm going to stop sharing, and then I'll share again. Right, everybody can see that, correct? Now we're on the Sage Modeler program.
Yes.
Yeah, good. Thank you. So I opened up Sage, and I'm going to open up a file from my computer, one that we worked on yesterday, because there's a couple of points I want to make. So I'm going to drop one of the models I made yesterday. Huh. That's weird. Well, I think everybody can see this. We'll just, I don't, shoot. I'm going to quit and come back in. So don't, let me quit where I was, and I'm going to come back in. I wanted to show you that model. I'm not sure why I can't open it. So I'm going to launch Sage. Create a new document. Oh no, I don't want to create a new document. I want to open an old one. Files. Okay, well, that's too bad. Well, that's okay. I'm just going to go to a different one.
I think you can actually open the link that we actually shared yesterday, the one that you shared also the link for the one inside the Google Drive, something like that.
Yeah, I'm not sure. I think we're okay. I opened it up earlier this morning. I'm wondering if I did something. I didn't save it. Maybe I needed to save it. It's all right. We'll just go play with this one. I'm sorry. We'll go play with this one for now. So this is one of the models we built yesterday. I'm just gonna close out of this data. I don't really need this data, so I'm gonna just throw away this data. And I'm just gonna close this for now. So if we want to collect some data and we want it to be numeric, the way you do it is you click on this your independent variable. I'm sorry, you click on your dependent variable. In this case, it's academic achievement. You can go up to then you'll notice that on the right-hand side, because I clicked on my dependent variable, you'll notice that on my right-hand side, my tools lit up. So I'm going to click on the ruler. That's a little ruler because it's talking about how you can collect measurements. So I'm going to click on that. And right now, I guess I was playing around with it. So you can actually go back and forth here. When you click on the ruler, it says switch to define with numbers. So I can click on that. And when it says, when you do that, then the data you collect should be numerical. And of course, what you want to do is you want to come to each one of these, click on the ruler. And again, I've already said switch to numbers. So it's going to be all switched to numbers. Same thing with this one. So now when I go collect data, I'm going to simulate. And there's a little bit of a glitch. Sometimes you have to do it more than once. But once I'm going to just say record continuously. And I'm just going to collect. There you go. So you'll notice that in my data table, instead of having just lines, I'm going to stop recording. You will notice that I now have numerical data. So you can collect numerical data with Sage. You just have to use that tool. And if I go and graph it, my data ends up on my graph, and I'm going to put my dependent variable, because it depends on the amount I study and the quality of the instruction. I'm going to put that on my y-axis, because we always put the dependent variable on the y-axis. And on the x-axis, I'm actually going to put the amount I studied. And there we see a relationship. Now you see the points, but now that you see the axes are also numerical. So you get more of a numerical sense of what happens. And you can do this on any of the static graphs that you collect, or even any of the dynamic graphs. You can always change it to a numerical value if you have one. In this case, we don't really know what the numerical values are, so it's a little bit strange. But so you can put it in there. So when I did this, I put it at sort of like percent of time, right? So that's why it's in up to 100 and stuff. So are there any questions related to how you set numerical values?
I think I'm not sure how, but the thing is, I missed out on the part whereby I put in values. I try to use the same thing with values, but eventually, after switching with it, it still came out with the graph or words.
Right. So sometimes you have to go back and forth. I didn't quite hear you. You were a little, your voice did not come out clearly for me, unfortunately. But sometimes, like when you click on this, and you go to you go to the ruler, because the ruler is what tells you you're doing measurements. sometimes you have to click back and forth on this. And I'm not exactly sure it's a bug. I'm going to talk to the programmer. I'm not the programmer of the system. So sometimes if it's not coming out numerical, you have to click back and forth. And I'll try to show you that in another model a little later on. So we're going to examine a model, and later on when we examine that model, I'll go through this once again, step by step. The other thing I wanted to point out to you is that Sage actually comes in a variety of different languages. So if you go to the top right-hand corner, right now we're in English because we cut across multiple countries, and because we cut across multiple countries, we're using English. But if you click on this thing where it says English, you'll notice that there's a variety of different countries, which we have. We have Spanish, we have Chinese, we have Portuguese. We can actually change it working with you to put it in your home language if that's something you're interested in doing. So I can send you the instructions, or I can get you the instructions. As long as you have someone that's a little bit computer savvy, it's very easy to change the text that's on Sage Modeler into another language. And so, there's numerous different countries that have it in their language. And if you'd like it in your language, like if you want to change it to some other language, just let us know, and we can certainly change it, and we can work with you. You're going to have a person, but we can work with you to make sure we can put it in your language. Any questions on that? Okay, I'm going to stop sharing. Oh yeah, which one? I didn't realize that. Which one is Thai up here? This is
below
Thai, this one right here?
Portuguese? No, it's below Portuguese.
This one?
The one below Portuguese.
Oh, there. Okay, the one below Portuguese. Very nice. I was wondering if it was in Thai. I can't remember when we did that, but I guess we did it at one time. That's great that it's in Thai. So that the people in Thai can always change it into Thai. But we can certainly change it to other languages as well. I mean, it's not too challenging. Okay, I'm going to stop sharing here. And then I'm going to go back to my PowerPoint. Okay, maybe not. So I think everybody can see my screen. And if there's no questions, I don't see any in the chat, then I'm going to move on to the next little part of our activities for today. So what I want you to do is I want you to go into breakout rooms just for a little bit. And I want you to examine and discuss the model design guideline for 5 to 10 minutes. If it takes you less than that, just pop out and come back into the main room. I want to see if you have any questions about it. So you can click on this, on the model design guidelines, and it will pop open for you the model design guidelines. And what I'd like you to do is read them. You might want to pull up one of your models, the model that you used yesterday, and using that as an example, read through for model design guidelines for static and see if you're okay. You do not, at this time, do not look at the dynamic time-based models, because we haven't done that, and that'll just add to some confusion. So all I want you to do right now is we're gonna pop into breakout rooms. You're gonna discuss just for a couple of minutes, for 5 to 10 minutes, the model. You're gonna read it and then see if you have any questions, and then we're gonna come back and then we'll move on to another activity. So I'm gonna give you 10 minutes to go in the breakout rooms and look at the model design guidelines. So Buren, can we put them into breakout rooms?
Yeah, sure.
just trying to put two variables. It's something like I want to say some examples between two variables which are not directly connected. Okay. I found this.
I'm sure you're doing fine. Okay, I'm gonna pop out and go to another breakout room.
Okay.
Then I'm going to close the rooms.
Okay. Yeah. Bu Indah, Pak Ari, and also Kim, are you okay?
Yeah, boom.
Okay, I think we're all back. And I just wanna, I'm gonna now go to the model design guideline. So I'm gonna stop sharing and I'm gonna share again. And the reason I wanted you to look at this is that this can be a really nice, handy sheet for you to use when you're examining other people's models or your own. So one of the workshops, one of the rooms that I went into, for instance, they were talking about the first one, and they were really focusing on this notion that whenever you define a variable, the variable has to have something that can be measurable. Otherwise, it's not a variable. So it has to have a scale that can go from low to high, or from 0 to 100, or from 0 to 50, however you want to define it, if you're on the quantitative scale. So you want to put variables in there, and you don't want to put objects. So for instance, I can be an object. I'm a person, I'm a human being, I'm an object, but associated with me can be a variety of different variables, my height, my weight, etc. So you want to know the difference between objects and variables. So you're always putting variables into Sage that can go from high to low. And so these, this little sheet, this little guideline, can actually support you when you're building models. For instance, are the variables linked in the correct direction? This is actually an issue that a lot of students do. They might put two variables together, but then they'll link them in a different direction. And so that's always problematic, right? So you always want to look, are the relationships in the appropriate direction? When you're testing your model and you're looking it over, you always look and say, are all these variables or all these parts that are in this model, are they really necessary? Often that's point number 3 here, bullet number 3. Often people will put extraneous variables in that aren't really needed to provide an explanation of the model. So you want to look for that as well. And then lastly, you really want to look very carefully and say to yourself, is the model actually running the way I expected? I thought that when I would increase one variable, if I would increase one independent variable, the dependent variable would go up, but in fact, it went the other way. So you're always checking your relationships to make sure they're working in the appropriate manner. So that's why I wanted to give you this sheet, because I think this sheet really can support you when you're actually constructing models. Are there any questions?
So, Joe, if, for example, we use a color as our variables, then we have to put scale for the color. For example, the light to dark color. Is it correct like this? Like that?
If you put color in there or transparency, then it would have to go from light to dark, right?
Okay.
You couldn't put color red, white, blue unless it doesn't know that, right? So if you have to put something that's always on a scale, like my weight, right? My weight's always on a scale. My height's on a scale. The height of a growing plant is on a scale. Water quality, for instance, pH is on a scale.
Okay. Yeah.
Anything
So-
that can change, right? Those are variables.
Okay. So, for example, we want to make a model for plant growth, and it depends on the length of the light. It means that sometimes we use a different color, blue, green, red, to check the different growth of the plant. So
Right.
for that cases, we have to use the length of the if we say for the length of the light or the intensity of the light.
That's right. You could say you could have two variables there. One would be both amount,
Yeah.
and the other one be intensity.
Okay.
So you
Yeah.
could so those are two different variables, right? How long the light shines on the plant is going to affect the plant growth, but also the intensity or the wavelength, right?
Yeah.
So you can have wavelength could be another variable, because it's the wavelength that gives the color. So that could be another variable, and you could study that as you change the wavelength. In fact, it does or does not have an effect on the plant growth. So you always want to make sure that the variable that you put in there can actually be on a measurable scale.
Yeah.
Does that help?
Yeah. Thank you.
Okay, so what other questions might you have related to this document? I find it a nice cheat sheet, if you know what I mean, right? It's a nice little handy little tool to have that you can look and when you're looking at other people's models or your own model to check for yourself, am I really building the model appropriately? So I find it valuable in that respect, and that's why I wanted to share it with you. I'm going to stop sharing my screen, and I'm going to reshare and go back to the PowerPoint. Okay, so now what we're gonna do is we're gonna look at what other phenomena should we model? Because I'm gonna break you into, you're gonna go into breakout groups and you're gonna construct your own model. You're gonna decide what phenomena you're gonna create and you're gonna build a little model. Hold on a second. Okay, sorry, I put the slide in the wrong spot. You really want to think about what's the phenomena that you want to model. And this is going to be valuable when you work with your teachers or with your students and you want to have them use modeling in your classroom. You want to really select model phenomena that are really related to your learning goals. So today you don't have to necessarily specify what the learning goal is, but I really do want you to think about what this phenomena is, and can the kids, can your students have firsthand experience with it? Would it be comprehensible to students? Would it actually be compelling to them that they want to answer? And will it spark other questions? So I'd like you to, we're going to break into breakout groups, and what you're going to do for about 30 minutes is you're going to, I'm going to back up just for a second. I took out one of my slides that I didn't mean to do. Okay, before we go into breakout rooms, I'm just going to do one little activity with you. Sometimes when you do modeling, it's really important to examine another model. So I guess that's this page, but somehow it got misplaced. So if you go to this one, it says, let's examine a fairly complex model. Sometimes when you just examine a model that someone else built, it can be really valuable. So we're going to go to the Building Sage Modeler resources. And I'm going to now click on launch this. Oh, you can't see it. I got to switch screens. Stop, sorry. Okay, hopefully everybody's here. And I'm going to click on concord.org.sagemodeler, and I'm going to show you why. When you go to this page, that everybody can see this page that says Sage Modeler, et cetera, et cetera.
Yes.
Yeah. Okay, good. Thank you. If you come down here, you will notice it has example system models. And this gives you a collection of really a variety of different kind of models that you can explore. So I'm going to open, it says browse examples. And of course, we're working with static models, so I'm only going to pick a static model. But these are models that you can go in. You'll notice how it's a static, right? Or dynamic. We're going to go and we're going to explore this epidemic static model because it's a little bit more complex, and it's going to give us an opportunity to review some of the factors, some of the ideas, some of the principles that we've already come up with that's going to allow you to go design your own model. So I'm going to click on this. And it opens up a model that hopefully everybody can see. And let's try to understand what's going on. So I see a bunch of arrows going in one direction, and they finally lead to my dependent variable. Remember, dependent variables are the variable that changes as a result of doing something. And it's our outcome. So it's the number, because I'm dealing with an epidemic, it has to do with the number of infected people. So we see that right here, the number of affected people. And we can now go back, we can now trace it. It basically says that the number of infected people is really dependent upon the number of new infections, right? And that's a direct positive relationship. So there's that red arrow. There's also the number of new infections, of course, is also dependent upon how effective the disease actually is. So is it a really strong effective disease, or is it a mildly effective disease? And of course, that will then go, and that's also a positive relationship that's indicated by the red line once again. We can also continue to look at these various relationships. Here we see one that's it's now a blue line. Remember, the blue line says it's negative, and we see the effect, how effective is the vaccination program that we have. And of course, the more effective it is, it's going to decrease the number of new infections. And of course, how effective it is really depends upon how effective the vaccine is. So those are related. So I just want you to take a couple of minutes and sort of just look at this model, because it can really help you in your own building of your own models. And then we're going to go collect some data and review some other parts. Okay, with that, I'm going to actually simulate this. And I'm going to, and you'll notice now when I say simulate, right, I'm going to go back. Remember, the simulate button is at the top. You can click on it. And when I simulate it, you can notice all the independent variables. Those are the variables that I can change, end up having a slider on them. And of course, if right now it says that that the disease is very effective. It's a very infectious disease. It's very high, but I can reduce it. I can make it not as infectious. And when it's less infectious, of course, the number of new infections goes down, and so does the number of infected people go down. But when we have a disease that's very infectious, then of course, the higher it is, the greater would be the number of infected people. Of course, I can sort of keep this at a minimum, a medium effectiveness, and I could then say to myself, well, I have a very effective vaccine program, so that's why I don't have too many new infections. But you'll notice when I make my my vaccine less effective, right? I'm now over in the top left-hand side. When it's not as effective, there's more people that get sick. And when my vaccine program is very effective, there's less, right? So it changes. Now, if I make the disease very strong, making it really high, and then I change my, you can see what happens to the number of, it changes, right? So we want to make sure that our variables are all working. So now we're going to collect just a little bit of data, but I'm going to collect it. I'm going to make it quantitative. Right now it's all qualitative. So I'm just going to put this all kind of at a medium level just to begin with. And I'm going to click on my number of infected people. And I'm going to come over here. Remember, if I want to change it to be numerical, I have to go to the right-hand side. I'm going to look for the ruler, because the ruler allows me to change from text to numerical. And then it says switch the numbers. So I switch the numbers. And I'm just going to, once I do that, all of my various variables are all switched to numbers. Actually, I have to change each one independently. So I switched all my independent variables to think I did that. Yeah. Yep. So hopefully you're following along and you're doing this yourself. So now let's go collect some data. And now we should have empirical data. And so I'm gonna say simulate. I'm gonna say simulate. And I'm gonna just record one data at a time. And I'm gonna start off with not having a vaccine program effect, not having a very strong vaccination program. And I'm going to start off with the disease coming in that's fairly strong. And yet I have a lot of people in my world that are very susceptible. So those are, and a lot of people are talking, we're all going to parties and gatherings. And so when you have a very infectious disease like COVID, and you have a lot of susceptible people who can get sick with it pretty easily, and the number of people that are coming in contact with each other because we're out and about, you're going to get a lot of infections. That's what this says. So I'm just going to sort of record that data point. And for some reason, it did not pop up. All right, let's go back. I forgot to change one of mine to numbers. So I'm going to sort of clear that case again. And of course, I don't know if you guys noticed this. You can also always get rid of data if you'd like by just clicking on the garbage can that's over here. And you say select all cases and delete all cases, and it goes away. So I'm going to now see if I can't collect some numerical data. Hopefully it'll now be numerical. And so I'm going to, still didn't come out numerical. Well, let's change it and see what happens. What I'm going to do is I'm going to increase the effectiveness of my vaccination program. And I'm going to record that data point. Record some more data points. And I'm just going to go back and check this again. Well, sometimes it works and sometimes it doesn't. Last night when I practiced, it did work. And oh, well, but again, once again, we can graph it. To graph it, we just grab a graph, and our data points go in there. And then the number of infected people is my dependent variable. So my dependent variable always goes into my y-axis. So I can grab it, I can put it, move it over there. And I then want to plot it with the effectiveness of my vaccine. And it didn't change very much. So if I have a very low, I'm going to sort of record continuously. Let's see how, I'm going to actually, before I do that, I'm going to get rid of my data. And I'm now going to come over here and I'm going to record continuously. And we're going to see what happens to the effectiveness of my, do the number of disease cases go down as a result of the effectiveness of my vaccine. So as my program gets better and better and better, you will notice that not much is happening. So that doesn't mean I have a very good vaccine. So maybe I want to have a good vaccine. So let's go look at, let's stop recording data let's go and click on this relationship because it's going to the effectiveness of the vaccine. Ah, do you know why? Does everybody know why I got a straight line? Well, if you look over here, the number of vaccines was very low. No one was getting vaccines, right? It was on 0. So if no one's getting a vaccine, no matter how effective my vaccine is, I'm not going to make a difference. So I'm going to go erase that data again. Delete all cases.
I
Now-
have a question.
Yeah.
Can number of vaccination affect on effectiveness of vaccine if there is no arrow between them?
Well, it's going to the effectiveness of the vaccine program. Now you could change it, right? That's one of the things that's nice about modeling is that was a really good question. And one of the things you could do is you could actually modify this program by this model by changing the arrow. So right now, the number of vaccinations is going to the effectiveness of the program, right? Because it doesn't really affect the number of vaccines the number of vaccination doesn't really influence the effectiveness of the vaccination. It really influences how good the program is, right? That's this variable. So I'm going to actually put this that a lot of people are running out and getting vaccines. And I'm going to make my, once again, I'm going to, let's just put that, let's collect this piece of data, right? Let's watch, I'm going to collect data. I'm going to record data about as the number of people get a vaccination, you know, what actually happens, right? So we see that the number of infected people go down. If you can see the thing going up and down. Now my graph, I'm going to get rid of this graph. I'm going to get a new graph. And what I'm going to plot now is number of effective people. Again, that goes on the y-axis because that's my dependent variable. And I'm going to put the number of vaccinations x-axis because that's my independent variable. Right. So now we get a really nice line between the number of effective people and number of vaccinations. So what we notice is that as the number of vaccinations go down, so as the number of vaccinations go up, the number of infected people go down. And that's what we would hope to see. We would hope to see that as the number of vaccinations increase, the number of infected people would actually go down. So I always love playing around with other models that people created. But again, SAGE isn't for you to create a model and give it to your students and use it as simulation. SAGE is actually to get kids to create models. But often when you're trying to learn about how to use the tool, once in a while, it makes a lot of sense to just go and explore a model to see if you can understand all the various parts that are in it. So one part that I'm suggesting to you is if when you get time, you can actually go to that Sage Modeler site and download a variety of, download 1 or 2 different models and see what happens. That's a really nice way to actually learn about modeling. Okay, so with that now, I'm going to stop sharing this. And I'm going to now share my PowerPoint again. And what we're going to do now is we're going to go back into what phenomena should students model. It's really, you're going to pick a phenomena. You're going to go into your breakout rooms. You're going to talk with your colleagues in your breakout room. You're going to pick a phenomena that you want to model. You're going to build that model. You're going to share your model. Hopefully you'll remember how to share your model. If not, I'm going to try to make it to all the breakout rooms. And I'm going to give you, again, I'm going to be going in and out of the breakout rooms. Hopefully Buren can go in and out of the breakout rooms too. And if you don't need 30 minutes, then we're going to bring you back. But I really want you to build your own independent model, because this is really going to be the test. Remember, formative assessments are great because it really tells the instructor, did you really learn everything I was hoping you'd learn? So this is going to sort of be, did you really learn all the things I was hoping you'd learn? If you can build your own model, pick a phenomena, right? What's the question that you're trying to answer about that phenomena? Then you're going to select your variables. You're going to make those relationships between those variables, and you're going to test your model. If you can do all those things in 30 minutes, then we can say, wow, you learned your lesson. We did a good job. And so we're going to come back, and you're going to spend a little bit of time actually sharing your models with the rest of the group. So again, because it's really critical to be able to share. A good question. A question in the chat was how many variables that you should have. You certainly need a dependent variable. And I would love for you to have at least one or two, at least 2 or 3 independent variables, right? So remember that independent variables are the things you can change, and the dependent variable is the thing that changes. And so we want to have one dependent variable, which you are always going to have one dependent variable. And then you want to have several, 2 to 3 independent variables that you can actually change. You might actually even have another independent variable affecting another independent variable, like we saw in our last model. So that's fine too. Let's just see what you can come up with in the time period we have. Any other questions related to this little quick assignment? Again, this is up to you. You have to pick your own variable. You can use that guide sheet that we had before to test yourself. Are you doing everything you're supposed to do? That's why I kind of shared that with you. And now the big goal is, did you create your model? So let's go check and see if you actually created your model. Or let's go check. Let's go into the breakout rooms and let's have you actually create your models. I'm actually going to give you 5 minutes to get started. And then I'll pop into the breakout rooms. Yeah, but must be like air, right?
Yeah.
Anyway,
Okay.
we will
It's
title them.
probably
I
there.
guess it's
Yeah,
okay, no?
okay. What else? A
Is
temperature,
yes.
Like a health at temperature and then
yeah,
global
average
warming.
temperature. What was with global warming?
No.
With temperature, this one?
So if true, the thermometer is the doesn't tell anything about the global warming. So why don't you just type right at global warming?
Okay.
So if
Wow.
Fire.
Earth and
That's
fire.
about it
Yeah.
nowadays.
Angry sun. Okay, I will choose this one.
Okay. But I guess the our first globe is nice as well. Like it's melting there, like a continent. It's
Yeah.
melting on the first
Wait,
one.
this one. Yeah,
Yeah,
okay.
it's nicer. At least it's not on fire.
So how to delete?
You don't need. You can
Okay.
leave it.
So our independent variables are factories, amount of cars, amount of trees, and our dependent variable is amount of carbon dioxide.
Mhm.
And next one is global warming here. Okay. Amount. What word is better, amount or number?
Emission. No.
Amount of
No.
number of what? Of
Factories.
Why when you change this one, when you
Yeah.
change that one is also change, right?
No. We just have to select here. So
Mm-hmm.
we talk about deforestation.
Okay.
If the number of it means that if so many trees cut in,
Yeah.
and the biodiversity
Is
will
it less and less?
go less, right?
Yeah.
Is it correct? Okay. Oh, I think this one. Oh, but it should be. Let me think.
Yeah, I think it's backwards. Go, click back on your, let's go back to it. Pick your
Oh. Which one?
let's go pick biodiversity since that's your dependent variable.
Yeah.
Let's go look at the relationship again.
Okay.
And let's click on deforestation. And so
Yeah.
it says an increase in deforestation causes biodiversity to what? Increase or decrease?
Decrease.
This one is increase in deforestation means will
Causes-
be decrease the biodiversity.
Right. So how do you, so what you have to click on the arrow and select decrease.
Oh, this one. Okay.
Yes.
And then this one will be which one?
See, so now when you look at the graph, it says
Deforestation increase
increases,
and
biodiversity decreases.
yeah.
And this, by the way, this little discussion that we just had is, I find, one of the most fruitful aspects of kids building models, because they'll go through the same thing we'll do. They'll not select increase or decrease correctly, and then they look and they say, just like you noticed, you say, but the arrow's wrong, right? It should be blue, and it was
Yeah.
red. Right? And so that gave us a hint. Something's wrong with our model.
Yeah,
And
so I just remember the
Oh.
color of the arrow.
Right. Right, that's what you did, right? So that caused me to say, okay, well, then she's right. It should be blue. So so we need to go look at our relationship again, right? And that's what we did.
Yeah.
And even though you were saying it correctly, an increase in deforestation causes biodiversity to decrease. You didn't select decrease, so you have to select decrease, right? So
Oh, okay. So like this one.
yeah, now it's blue.
Thank you. Okay, so the second one we have to think also, because deforestation will be also impact the climate
change.
Yeah, so it means we have to put the climate change here as a independent variable. Right.
In it.
So I think I have to write down here. I should put the picture here.
Mm.
Let me change. We cannot.
I think just move the climate change. If you move the climate change, it'll work.
Oh, okay. Oh, I see. Okay. So the climate change will decrease if we no. If deforestation increase, then there is the climate change impact will be increased too.
Mm.
So it means that I have to, like here, increase, then more and more. Okay. And then the climate change also have impact in biodiversity.
Was it?
Is it correct, Kim?
Yeah.
Say that again, then, what was the question?
So
Uh,
we think that climate change also impact on biodiversity. It means if climate change became worse, and then biodiversity also became worse.
That's correct.
Yeah.
mm.
So for example, if deforestation happen, then the temperature will be increased. There will be global warming. Then global warming will be impact on the species who will be survived. So it means that biodiversity will also be decreased.
Mm.
So here I have to also make the relation, or I cannot. So I
Yeah, you can just, you just missed it. Just try it again.
yeah. This.
It looks like you guys are doing good, so I'm gonna pop up, I'm gonna go to another breakout room.
Yeah.
The only thing I'm gonna
thank you.
suggest that you do is if you could write see, I saw that in the text box, you wrote biodiversity, but what's your question? Remember,
okay.
models are always driven by questions, so if you could
Okay.
put your question, that'd be great.
Yeah.
Otherwise, it looks good.
Mhm.
Make sure that you try to collect a little bit of data. So you can,
Okay.
and save your model so that you can share it with the rest of the group.
Okay.
And be prepared to talk about some of the conversation that you had.
Yeah.
But good work. It looks like you're making good progress.
Okay. Thank you, Joe. So the question is, what factors impact biodiversity? What factors?
What are the factors? Right? What factors impact the biodiversity?
Yeah. So we have to make question like this. What factors
Go. Yeah.
What is the line and the middle?
The middle, it's because
Yeah.
we do play around just then with the when we play around with the sun, the time exposed to sun means the amount of sunlight here is in between here and the amount of macronutrient and macronutrient. We can clear the other data to ensure that we only get the data when we're playing
Okay.
with the amount of water.
Mhm.
So
I see.
let us clear the data just so that we can see the data clearly. So delete all case, okay. Let's see now, let us play with only water.
Okay.
Yeah, then we can see that the data is only recording for the amount of water towards the height of the cloud. And then depending on situations, we can actually output the pH value as well as time exposed to sun and the amount of macro and micronutrients.
Mhm.
So I think by testing our model, it looks okay.
Yeah, you look like you guys are doing good. I only have one suggestion.
Yeah.
make sure that, I saw that you have your text box up, but it says plant growth. And what's the question that you're trying to answer? Remember, models answer a question, not plant growth, which is a topic. So what's the question that you're trying to answer?
So the textbook should be the question, is it?
Right, so type your question in and not just the topic. Otherwise, it looks like you're doing really good work. So I just want to just make that one little suggestion. And don't forget to save your model so that you can share it with the rest of the group, and also be able to discuss what was your conversation like as you built this model? What were some highlights of the conversation? But it looks like you're doing some really nice work. And so with that, I'm just going to leave and pop into another breakout room.
Okay, thank you, sir. So, do you think any addition that we need to get to make the model better, or another? Do we need to add in another variable? What do you feel?
Like the winter, like a
Yeah.
whole winter.
So it's not measurable at the moment. I think we need to write something and another. What do we mean by global warming? Something measurable, like sea level.
Yes. Or the amount of
melt
ice,
ice
like a melt.
Amount
Yeah.
of ice,
or
Yeah.
the glaciers.
amount
Not-
of
not-
penguins, amount of penguins which died.
No.
It's depend on you. Okay. Yeah.
Maybe the
Okay, it will be global warming.
maybe the size of the glaciers. No,
Yeah.
Size of the
It's-
what?
glaciers.
Что это?
The glacier. You mean
Yeah.
the big ice?
Like the glaciers will melting
Ice,
per year.
the big ice in the water.
Yeah, just so you just tie the big ice. Okay.
Like
just-
Okay.
Greenland now it's not so big as it used to before.
Yeah, that's right.
It's
The
the
glaciers-
enemy of Titanic.
Right, so the amount of water, the amount of ice, it's basically the amount of ice in trapped in the North Pole, the South Pole, and in the glaciers, right? So that's what I think that's what you're referring to.
So should
Uh,
we retitle it like instead of writing the global warming, write the amount of glaciers or?
You could, but actually global water is a variable, right? So you can have little global warming and a lot of global warming, right? So it is a variable that can change, but you could also, I like your idea that as an indication of global warming is the amount of water that's trapped in glaciers, right? So the glaciers over time are decreasing. I actually like that idea a lot. And it probably makes a lot of sense to put that there. So I like that idea. So
We can change the global warming icon to the like glacier one.
or amount of ice in the earth, something like that. There you go.
penguin.
They don't
Ah,
look like that. Oh, the Greenland there.
Green as this.
No, the Greenland is a land next to the mountains, I guess. No. Yes, and just that's the
Yeah, I think
Greenland.
it's Antarctica.
No, it's not
Yeah.
Antarctica. It's Antarctica.
Yeah,
Yeah.
Antarctica.
Okay. It's also
Anyways,
melting.
I'm gonna pop into another breakout room. I think you're doing a really nice job. Be prepared. Try to see if you can't within the next 5 minutes collect some data. I also remember that every model has a question that's associated with it. So if you could add your question by using the text box to your model, that would be great. So don't forget to save it. Save your model, and so that you can share it with us. And yeah, and be prepared to talk about your model as well as what was the nature of your conversation, right? That's what I'd like to hear a little bit about. What was the nature of your conversation? So looks like you're doing good work. So I'm gonna pop out and go to another breakout room.
Thank you.
And you have about 4 minutes left, and then I'm gonna close it down. So make sure you try to collect some data.
How are we gonna title the model, like effects of the carbon dioxide emission or something like that to the earth, but it sounds more expanded.
What was it? Was this question to our team or to Joe?
To our team, we should title our model. So we should put the question like, what's about our model?
Uh-huh.
This one is to show our data, but
Yes.
let me take it. What wrong? Okay, so let's stop first. And then I forgot how to make it continuously. Oh, should we look at this one?
16.
This one is not. This one is just to define the number. Or this one? Like this one. Why my table did not show me?
First.
Well, I can do it. Hold on. You want to go with Peter? Oh, you're in Peter's room.
I move her to Peter room.
I think we're all back. I'll just give it a few more seconds. I had a nice time jumping into your breakout rooms and listening to you and watching you work. It looks like you've made some progress in understanding Sage and how Sage works. I actually really also enjoyed watching your models and the kind of models you selected. And so what I'd really like to do now is have groups share their models, and let's see how far we get. I don't know if we'll get through all of them, but I'd like groups to share models. I'm gonna stop at 5.2 because I do want to show you something really quickly. If I don't get through with all the groups today, I think first thing we'll do tomorrow, if the group wants to share, we'll share it tomorrow. But I would like you to use your model design guidelines to provide feedback. So you can look at it, you can ask yourself, are all the variables there? Are the relationships okay? Do the relationships actually explain the phenomena? So I'd like the groups to, groups just basically, we had 3 groups. If they could just share their model to us, and also I'd like you to just spend just a couple of minutes discussing the kind of conversations you had in your rooms and the value it would have for students to get involved in those kind of conversations. So if we could just have groups share their models, and we'll do, hopefully I can give each group about 5 minutes. So let's go to each group. We could go either room 1, 2, or 3, or we could just, go as we please. What group would like to go first?
We can.
Okay. Which group are you? You were group, I don't remember.
2, not number 2.
Group 2. Okay, let's have group 2 go first. And who, okay.
So we have a speaker.
That's okay, Darren. We all have kids. We know what kids do. So can you
No, I
explain
mean,
your model?
we tried to choose like dependent variable is the concentration of carbon dioxide. So we chose 3 independent variables: the amount of factories, amount of cars, amount of trees. So here's directly proportional amount of factories and amount of cars, because increasing amount of factories can increase concentration of carbon dioxide in the air. So something similar with amount of cars, but with trees is opposite. So increasing the trees can decrease the concentration of carbon dioxide. And also we added 2 more dependent variables. For example, concentration of carbon dioxide can affect on average temperature, and average temperature can affect on global warming. So we collect some data by changing amount of factories, also by changing amount of cars. But I didn't understand how to draw a graph when we have, for example, several dependent or independent variables.
Yeah, you can only change them one at a time, right? You can't graph multiple things at one time. You can only graph one at a time. So you can hold one thing constant, right? So you could put your amount of trees as medium, your amount of cars as medium, and then you can change your amount of factories and watch its output. And then you could have that on one graph, and then you could put the amount of factories at medium and the amount of trees at medium, and then change the amount of cars. And then you could compare them next to each other, right? So that's the best way to do it. And one of the nice things about tomorrow I'll show you a really another nice feature about Sage. You can actually overlap the graphs. So there's actually a way of making the graphs transparent, so you can put one on top of the other, and that way you can compare somewhat, right? You can either look across or you can compare across. So that's the best way to do that. I was wondering if you could describe the nature of your conversation in your group. Right, so this is nice. It shows that the amount of trees, as the amount of trees increases, the concentration of CO2 decreases. Similarly, the amount of concentration of CO2, as concentration of CO2 increases, temperature increases, right? So this is, you have two very nice relationships here.
Yeah, we chose this type of graph because we think after some value, concentration of carbon dioxide, temperature cannot increase constantly. We think, for example, maybe 60 degree or 50 degree by Celsius.
There probably is a limit, because everything is going to die, so it's just going to stop.
Yeah. So amount of cars will decrease.
Right, there probably is a limit.
Yeah.
So what was the nature of your conversation like?
Nature of our conversation.
Yeah, what did you guys talk about? Would you find it valuable for students to have the kind of conversations you had?
I think we just did a model. We spent some time to choose a topic. I mean, before this one, we discussed about effective of mass of planet and radius of planet on acceleration of free fall acceleration.
Oh.
So then we chose this topic.
Yeah, I think because we are different in major, so we have physics, chemistry, and biology.
Biology.
Yeah, and the first topic that we talk about is quite difficult for me, like in physics. So we all of us come up with this topic because I think that is makes sense for all of us. Yeah, and then.
And it's an important topic.
Yeah, and everyone has some background knowledge or some understanding. So like people also and student also should have some knowledge before like plotting the model.
Okay, very good. Nice model. Please, I'm gonna, if you could, please save your model to the Google Doc. If you go into the Google Doc and you into our folder here, I'll show everybody. I'm gonna quickly share my screen. I want to make sure that we do this before we end today. So no, that's not what I want. Sorry about that. I'm gonna share my screen one more time. I'll do this. So can everybody see the Google Doc?
Yes.
Yes, okay. So if you go into come into here, you pick you go into the Thailand 2023, you go into day 2 Sage Modeler, then you'll see models day 2. If you could save your models to that would be great. Remember, put your name next to it, and put your models in here, and then we have that we can refer back to. So I'm going to stop sharing. And if I could have another group, either group 1 or 3, share your model, please.
Yeah, group 3 will try to share.
Okay.
Yeah. So me and Wait for a while. Okay. Me and Kim, we are both from biology education. So we discussed about biodiversity and what factors influence biodiversity. First, we think about number of new species as our first factors, and the second one is deforestation. And then we also think that if there is change in our climate change, then will be also impact to our biodiversity. So our question is, what factors impact biodiversity? Then here the relationship that if the number of new species increase, then biodiversity will also increase. And if deforestation increase, then the biodiversity will decrease. And then we also think that deforestation will also impact the climate change, and the climate change will also impact to biodiversity. So we tried, I tried 4 experiments, but I think I have difficulties on showing the data of the experiment. And then our graphs looks like this one. I think because of we put 3 experiments here, 3 or 4 experiments here. So the relationship between biodiversity and deforestation, it means that if deforestation decrease, and then the number of biodiversity will increase. That's
Okay, so let's, can I give you a little bit of feedback?
Yeah.
Remember, biodiversity, is it your independent variable? Is it the variable that you can change? Or is it the dependent variable? It's the one that changes. Which one is it? Is it independent or dependent?
It's independent. So it means that it will change if the number of species increase. The number of species of new species is dependent variables.
No, well, so remember, biodiversity, right? You're showing me on your graph, on your screen, that biodiversity will change depending upon the climate change. And of course, climate change will change dependent upon the deforestation. So the variables that we can change are deforestation. So deforestation is going to be an independent variable. It changes, it can change, it's independent. Biodiversity depends, right? So that's the dependent variable. It depends on deforestation. So one of the things you want to do is make sure you put the biodiversity on your y-axis. So let's just go collect some new data. Let's erase your old data. If you could put your table up. Let's just close all those.
Okay.
Right, let's just close all those. Close that one too.
Yeah.
Yeah, close that one.
Which
Okay.
one?
Okay, it's gone. Now let's collect some new data. Okay, so let's put the number of new species at sort of a mid-range. Because right now you don't have any species in there at all. So let's just put it at a middle range.
Okay.
Okay, that's good. That's fine. Now let's go collect some new data. So let's simulate.
Oh, I have to stop simulate first. This one? Oh no. Simulate.
Yeah, let's
In the
and
mid.
let's that's good. Keep that there. Let's now collect some data. So let's record continuously.
Yeah.
And let's change the amount of deforestation. So right now you have lots of deforestation. Let's decrease it.
Okay.
Okay, good. Now let's stop recording.
Yeah.
Oh, we need a table. Select,
Yeah, I cannot show the table.
click on it,
Click,
drag it down, click on it and drag it,
which one?
table.
Table, this one?
Yeah, table, click on it and drag it down.
Mm, mm, mm.
Okay, well, if you save your model,
I
I'm
can-
gonna go look at it. And then I can see what's going on, okay? So let's just make sure you save your model to that document like I suggested.
Okay,
And then I will go look at it. So remember what you have to do is you go to click on your arrow. And
save,
you want to say share.
share.
Mhm. You want to get the link. Enable sharing. And then what you want to do is you want to copy the link. Yes, copy the link. And then go and place it in the document. And what I'm gonna then you can close, stop sharing, and then I'm gonna have the last group quickly share.
Okay.
And I'll go look at your model. If you want to stay on, we can actually spend a couple of minutes afterwards, see what's going on. But let's have the last group present. Whereas I think is that group, I don't know what group that is, group 1 maybe? It's either group
Yeah.
1 or 3.
So may I present right now?
Yes, Peter, please share your model.
Cool. This is supposed to be our model, of which what we are doing is the factors that is affecting the height of plants. So we have the amount of micronutrients, we also have the sun exposed to sun, the volume of water, as well as the pH value of the soil. So there are also other factors that are contributing, the other variables that are contributing to pH value, for example, as well as the macro and micronutrients, of which contribute to the amount of nutrients. So if you were to if you want to see the graph, okay.
Okay.
So let us see, with the amount of volume, we set it in between medium. How about the mass of the decaying materials? Let's see, maybe about regular, slightly small. The amount of fertilizer from agriculture maybe a bit more, something like that. Medium.
Right, but you need to, if you're not collecting any data, if you want to collect data, you have to click.
I haven't collected any data because currently I'm making the constant variable.
Okay, good. Thank you.
So currently the constant variable is the other three factors, the other variables, which is the pH, the volume, as well as the time exposed to the sun. As for the amount of the nutrient, it's the one currently we are making as the responding variables. The manipulated variables. So for the amount of nutrients, I'm going to start recording on the amount of macronutrients. With decreasing amount of macronutrients, the data is being collected, as well as increasing that, for example. Stop recording. For the experiment, here, the attributes, I will actually use the amount of macronutrients, and here is the height of plant. So the graph looks like that because we believe that with a lot of nutrients, when we put in a lot of nutrients, also the height of the plant will actually reach to a certain height that it will not be affected by the amount of nutrients that we put in anymore. So yeah, this is one side of the graph. So if we decided to do a different factors right now, of which I'm going to do a second experiment. For the second experiment, let us do the volume of water. I'll set the macronutrient to be all at the average. For the recording, the volume of water changes. Okay, and then stop. here, it will be changed to volume of water, and the height of plant, yeah, the graph looks something like that. With a bit of water, the height of the plant is actually very small, and with the increase of amount of watering, it will actually increase. But to a point when we water too much, it will actually die also, because having too much water is not good for the plant also. So yeah.
Very nice. So you used the variable feature to draw that.
Yeah, basically, yeah, we draw the variables. We draw the variables features there for the, yeah, as well as for the time of the sun. That is also the factors that we actually, so this is how we see out for the sun, and this is for the volume of water.
Right. Very, very nice.
Yeah, that is all. And as for our discussion, I find that when we're working in a team, one person has to act as the leader or guiding everyone, and the others will give their input, and the leaders or the one who is actually writing down everything will be putting everything together. So I can see that from our discussion, if we actually do apply it with the students will actually have the one, it will train the students' capabilities to become a leader in a way of a leadership there, as well as the way they are able to properly work together in a cooperative manner. So yeah, that is what the input I got in our group focus on. Thank you.
Okay, well, it's getting towards the hour. I really pleased looking at all your models. You've really come a long way. This is really great for just 2-hour sessions over Zoom. We've really come a long, long way. So you should pretty good about your modeling ability. I'm actually going to work tomorrow. We'll start off by revisiting how you create numerical variables. I think I figured it out what I was doing wrong, hopefully, but we'll try that again tomorrow. And then we're gonna spend some time in helping you understand the difference between static and dynamic modeling. Because I think and then hopefully at the end to demonstrate your total knowledge, if we have time, I'm going to have you draw a model of water quality. If you flip through the PowerPoint, you could see that I wanted to get that accomplished today, but I went a little slow in the beginning and we didn't get as far as I had hoped. So, but you guys did wonderful work today. I'm really pleased. I actually really am pleased with the models. I hope you're finding building models with Sage models valuable. And I hope you can see the value it can have when children actually use, your students will build models, because it really gets them involved in conversations about important disciplinary ideas, how various factors actually work together, how various variables actually work together to influence a dependent variable, which is a very important idea. So with that, have a good evening. Please remember to share your models in that where I asked you to share it. Okay. And if that group wants to stay on, I'm more than willing to spend 5 minutes looking at your models. So if that chat, great. I'm glad you found it useful, Agama. Thank you.
So sorry, Joe. I couldn't actually access the document. I tried to answer. I tried to edit. It says I require access from the owner.
Yeah, yes, me too. So it requests edit access. So we need access to write down the link.
I will go do it right now. Huh, I'm surprised. Share. It says anybody with this link. Oh, I see. Viewer, editor. Okay, try it now, will you? Does it work now? I see some. Can someone try writing on it? I think
Yeah, I'm trying now, but still difficulties
Sure,
on
there.
internet connection. So I think it will take time.
I can edit on it.
Oh, okay. So that's okay.
Yeah, it works. That's good. I'll just share my screen. Yeah, let's see. Where is that? Okay, so we got two of them in there. Let's see what this one does. Was this the group that couldn't collect data? Eunice, is this your group?
It was our group.
This is your group here? So I don't have the one that couldn't collect data. I was gonna go look at it.
Joe, I still have a problem with internet connection here, so I cannot
So-
open the file.
Okay, can you put it in chat? Eunice, try to put your URL. If you put it
Yeah.
in chat, I'll put it in there for you. Okay, unfortunately, I'm gonna have to go. I have another meeting. Eunice, if you could somehow put that somewhere else on your computer, and then maybe when the internet's working better, you can either email it to me, or I can or tomorrow first thing we can look at it. So I can't help other. Oh, I got it. It came up. Good. Hold on, I got it.
I cannot open it also. I
Uh,
tried to click at the link, it cannot be opened.
Yeah, something's wrong. It says the same thing to me too.
Okay, so I will try later to put it in the
Yeah,
file.
try to copy. Just try
Yeah.
to if you go to can you see my screen? If you just copy, you can just copy it like this,
Okay.
right? Just highlight the link, copy it, and put it someplace safe so we don't lose it.
Okay.
Right. All right. Thank you, everybody. I will see you tomorrow.
Good
Yeah.
night.
Bye-bye.
Bye.
Thank you. Bye bye.
Bye bye.
Bye-bye.
Thank you.
Bye.
Bye bye.